In the spring of 1942, at Aberdeen Proving Ground, a quiet demonstration took place that would change the future of warfare in ways no one present could fully understand. There were no grand speeches, no high-ranking generals announcing a breakthrough. Instead, two engineers stood beside a crude, almost improvised device, something that looked less like a weapon and more like a piece of workshop scrap. Their names were Leslie Skinner and Edward Uhl, and what they were about to show would redefine how a single soldier could fight a tank. The device itself was astonishingly simple. A metal tube, open at both ends, a small rocket with a shaped charge warhead, an ignition system cobbled together using flashlight batteries and basic wiring. It didn't look like the future of anti-tank warfare. It looked like a field experiment that had somehow escaped the lab. But simplicity was exactly the point. For decades, tanks had dominated the battlefield, their armor growing thicker with every new generation. Infantrymen had few reliable ways to stop them. Heavy artillery could destroy tanks, but it was slow, cumbersome, and often not available at the exact moment it was needed most. What Skinner and Uhl were proposing was something radically different, a weapon that one soldier could carry on his shoulder and use instantly. The science behind it was not new, but its application was revolutionary. The shaped charge, based on principles developed before World War II, used a focused explosive jet to penetrate armor rather than brute force. Instead of trying to smash through steel with sheer impact, it concentrated energy into a narrow, high-velocity stream capable of burning through even thick plating. In theory, this meant that a relatively small warhead could destroy a heavily armored vehicle. In practice, no one had yet managed to turn that theory into a portable, reliable battlefield weapon. As the demonstration began, the tension was subtle but real. The engineers connected the wires, checked the alignment, and prepared the rocket. There was always a risk with experimental weapons: misfires, explosions, failure at the worst possible moment. When the trigger was activated, the rocket ignited and shot forward with a sudden burst of smoke and flame, leaving the tube with surprising speed. Moments later, it struck its target. The result was immediate and undeniable. The shaped charge worked. The armor was penetrated. What made this moment so significant was not just that it succeeded, but how it succeeded. The weapon required minimal training. It didn't depend on complex machinery. It could be produced relatively cheaply and in large numbers, and most importantly, it gave infantry something they had never truly had before: independence from heavy support when facing armored threats. Within months, the U.S. Army began to standardize and deploy the weapon. It would soon become known by a nickname inspired by a musical instrument, the bazooka. The name stuck, and with it came a growing reputation. Early versions, such as the M1 and later M1A1, were rushed into production and sent into combat zones where Allied forces were struggling against German armor. It wasn't perfect. The electrical ignition system could fail, especially in wet conditions. The rockets themselves were sometimes unreliable. But even with its flaws, the bazooka represented a shift in battlefield power. For the first time, a single infantryman could ambush a tank and have a real chance of destroying it. This changed tactics almost overnight. Tanks could no longer operate with the same confidence in close terrain. Urban areas, forests, and narrow roads became far more dangerous. Infantry units, once forced to retreat or call for support, could now stand their ground or even hunt armored vehicles. As shipments of bazookas reached Allied troops, the weapon quickly saw action in places where innovation was desperately needed. Soldiers adapted to it rapidly, learning how to position themselves, how to aim for weak points, and how to coordinate attacks. It was not just a new tool, it was a new way of thinking about combat. Instead of relying solely on large-scale firepower, the battlefield began to shift toward mobility, surprise, and individual initiative. Yet, even as the bazooka began to prove its value, it carried within it the seeds of an unintended consequence. War has always been a catalyst for technological exchange, often in the most unexpected ways. Weapons are captured, studied, and replicated. Innovations rarely remain in the hands of one side for long. The very simplicity that made the bazooka effective also made it vulnerable to being copied. Somewhere far from Aberdeen, future events were already beginning to unfold, events that would take this American invention and transform it into something even more powerful. The bazooka was not just a weapon, it was a concept. And once that concept was seen, understood, and reimagined, it would cross enemy lines and evolve. In 1942, however, none of that was yet visible. What existed in that moment was a breakthrough born out of necessity, ingenuity, and a willingness to challenge established ideas. Skinner and Uhl had not set out to create a legendary weapon. They had simply tried to solve a problem. But in doing so, they had opened a door that could not be closed. The age of the infantry anti-tank rocket had begun, and the battlefield would never be the same again. By late 1942, the deserts of North Africa campaign had become a testing ground not only for armies, but for ideas. It was here, among the endless remal and burning heat, that a new American weapon began to appear in the hands of Allied soldiers, the bazooka. At first, it was just another unfamiliar piece of equipment among many, but on the battlefield, even a single captured weapon can change everything. The conditions in North Africa were brutal. Sand-clogged machinery, heat-drained men, and supply lines stretched thin across vast distances. In this environment, equipment was often lost, abandoned, or captured in the chaos of fast-moving engagements. American forces, still adapting to the realities of World War II, occasionally left behind weapons during retreats or sudden armored clashes. Among these were early models of the bazooka. For German forces, especially units of the Afrika Korps, capturing enemy equipment was more than just an opportunity, it was standard practice. Every unfamiliar weapon was carefully examined, tested, and, if useful, exploited. German engineers and intelligence officers understood that innovation could come from anywhere, even from their enemies. When the first intact bazookas fell into their hands, they immediately recognized that this was not an ordinary weapon. At first glance, it seemed almost too simple to be effective. A hollow tube, a rocket, a basic trigger system. Compared to the precision engineering typical of German weaponry, it looked crude. But on the battlefield, reports told a different story. Allied infantry had begun using it to disable German tanks at close range, something that previously required coordinated artillery or specialized anti-tank guns. This raised an urgent question: how could such a simple device achieve such destructive results? Captured examples were quickly sent back to German research facilities. There, engineers began a detailed analysis. They dismantled the launcher, examined the rocket, and focused especially on the warhead. What they discovered was both surprising and concerning. The bazooka relied on a shaped charge, a concept the Germans were already familiar with but had not yet fully exploited in a portable form. The realization was immediate. The Americans had successfully turned this principle into a practical infantry weapon. Testing followed. German teams fired captured bazookas under controlled conditions, measuring penetration, reliability, and range. The results confirmed what battlefield reports suggested. Despite its rough construction and technical limitations, the weapon worked. It could penetrate armor effectively, and it could be operated by a single soldier. This combination of power and portability represented a significant shift in battlefield dynamics. But the Germans also noticed something else: weaknesses. The electrical ignition system, dependent on batteries and wiring, was unreliable in harsh conditions. Moisture, dirt, and wear could easily cause failures. The effective range was limited, forcing operators to get dangerously close to enemy tanks. And while the warhead was effective, it was not as powerful as it could be. To German engineers, these flaws were not deal breakers, they were opportunities. This was the moment when curiosity turned into intent. The bazooka was no longer just a captured weapon, it was a blueprint. German leadership, already invested in maintaining technological superiority, saw the potential immediately. If such a weapon could be improved, made more powerful, more reliable, it could give their infantry a critical advantage, especially as Allied armor became more numerous and aggressive. The process of reverse engineering began in earnest. Engineers documented every component, every dimension, every material. They studied how the rocket was shaped, how the charge was shaped, how the launcher directed exhaust gases safely away from the operator. Nothing was overlooked. At the same time, they began imagining changes, ways to enhance performance while eliminating weaknesses. What made this effort particularly significant was its speed. Wartime urgency demanded rapid results. There was no time for slow, cautious development. The Germans moved quickly, driven by the understanding that this technology could not be ignored. Every delay meant facing Allied tanks without an adequate response. Meanwhile, on the front lines, the psychological impact of the bazooka was already being felt. German tank crews, once confident in their armor, now had to consider the possibility of close-range ambushes by infantry. The battlefield was becoming more dangerous, more unpredictable. Even if the bazooka was not yet widespread, its presence signaled a change, a shift toward decentralized anti-tank capability. As reports and test results flowed back to command, a clear conclusion emerged. The bazooka was not perfect, but it was revolutionary. It represented a new category of weapon, one that combined simplicity, mobility, and destructive power in a way that had not been achieved before. Ignoring it was not an option. Somewhere in a German workshop, the first sketches of a new weapon began to take shape. It would not be an exact copy, it would be something more, something stronger, more reliable, more suited to the demands of German doctrine. The idea had been captured in the Ramal of North Africa, but it was about to be transformed into something far more formidable. What had started as an improvised American invention was now on the verge of becoming a German innovation. And once it returned to the battlefield in its new form, it would carry with it all the lessons learned from both sides of the war.
The Panzerschreck's impact was felt immediately on the front lines. German soldiers quickly learned that positioning was everything. From the hedgerows of Normandy to the dense forests of the Eastern Front, small teams could set up ambushes along likely tank routes. Unlike heavier anti-tank guns, which required transport vehicles and assembly, the Panzerschreck allowed infantry to move quickly, hide in buildings, or even fire from trenches, then disappear before the enemy could react. Its portability, combined with its raw destructive power, made it a force multiplier, particularly for units operating in terrain unsuited for tanks. The Germans also experimented with tactics that maximized the weapon's efficiency. Firing angles were studied meticulously because the shaped charge was most effective when striking armor at near perpendicular angles. Soldiers were trained to aim for weak points, the sides, rear, or even the engine compartments of Allied tanks. In cities like Cannes and Aachen, tanks that had once rolled confidently through streets were suddenly vulnerable to infantry lying in wait on rooftops, in basements, or behind rubble. One well-placed Panzerschreck rocket could disable or destroy a tank in seconds, leaving its crew with little chance to respond. Despite its advantages, the Panzerschreck was not without drawbacks. The larger rocket created a backblast that could injure the operator or reveal their position. Smoke trails from the rocket often gave away firing locations, making coordination and quick movement essential. Ammunition was bulky and heavy, and each soldier could carry only a few rockets at a time, meaning that sustained attacks required careful planning. Yet, for German engineers, these were acceptable trade-offs. The increased penetration and battlefield flexibility more than compensated for these limitations. Field reports from 1944 confirmed the weapon's effectiveness.
During the Battle of Tali-Ihantala in Finland, for example, small German anti-tank teams used Panzerschrecks to devastating effect against Soviet armor, destroying multiple tanks in coordinated strikes. On the Western Front, during the hedgerow battles after D-Day, Allied forces were shocked to find that tanks, which had once seemed invulnerable, could be neutralized by infantry with a single shot. Commanders quickly realized that tanks alone could no longer dominate the battlefield. The Panzerschreck forced changes in armored tactics, convoy formations, and infantry support strategies. This weapon also demonstrated the speed at which wartime innovation could leapfrog technological barriers. A simple idea, a rocket with a shaped charge, had been captured, analyzed, and transformed into something far more lethal within months. The Germans had taken the strengths of the bazooka, corrected its weaknesses, and scaled it up to terrifying effect. By the end of 1943, the Panzerschreck had become a standard-issue weapon for infantry, carried alongside grenades, rifles, and machine guns. Its presence alone altered how Allied forces approached infantry engagements. Yet the story of the Panzerschreck is more than technical improvement. It illustrates the brutal ingenuity of wartime adaptation. In many ways, it was a dialogue between enemies, an American invention tested in battle, captured, analyzed, and then improved by German engineers. Each side responded to the other's technological advances, accelerating the pace of weapons development in ways previously unimaginable. This cycle of capture, analysis, and innovation would repeat throughout the war, shaping not only the Panzerschreck, but the evolution of anti-tank weapons for decades to come. By the time the Panzerschreck reached widespread deployment in 1944, it had become more than a weapon. It was a symbol of the new reality of modern warfare. A single soldier, armed with ingenuity and technology, could threaten the armored might of an entire army. And in that sense, the Panzerschreck was not just Germany's answer to the bazooka. It was a testament to the power of innovation under pressure, and a harbinger of the way infantry would fight against tanks for generations.
By the end of the war, the story of the Panzerschreck had reached its climax, but its influence was far from over. The weapon had proven itself across countless battlefields, from the hedgerows of Normandy to the frozen forests of Finland, leaving an indelible mark on the minds of both those who wielded it and those who faced it. Yet the true measure of the Panzerschreck's impact would be seen not in the battles it won, but in the innovations it inspired in armies around the world. For the United States, encountering German anti-tank rockets firsthand was a wake-up call. Infantry units had previously relied on standard bazookas, but these were often inadequate against the heavier German tanks that had evolved by 1944. Engineers in the U.S. quickly set to work, learning from the very weapon that had been adapted from their own designs. The result was the M20 Super Bazooka, a larger, more powerful, and more reliable system. It addressed many of the weaknesses soldiers had encountered in combat: longer range, a sturdier ignition system, and a warhead capable of defeating thicker armor. In essence, the U.S. military had taken lessons from the battlefield and from enemy innovation to leap ahead in technology, a process that would continue in future conflicts. Meanwhile, in the Soviet Union, engineers were watching the war closely. Reports of both bazookas and Panzerschrecks reaching combat effectiveness inspired a new generation of anti-tank weapons. The Soviet RPG-2 and later the legendary RPG-7 owe a direct conceptual debt to the innovations born from this transnational cycle of design and adaptation. The principle remained the same. A shoulder-fired rocket launcher allowed a single soldier to pose a deadly threat to heavily armored vehicles. Yet the design was refined, simplified, and adapted to different logistical and battlefield conditions, proving that the core idea had far-reaching potential. The psychological impact of these weapons persisted long after World War II.
Tank crews, once confident in the invulnerability of their vehicles, now had to approach terrain cautiously, wary of ambushes from infantry armed with portable anti-tank rockets. Urban streets, dense forests, and narrow mountain passes became potential death traps. Conversely, infantry units gained a newfound confidence, knowing they could challenge even the most formidable armored opponents. This shift fundamentally changed the tactics of combined arms warfare. Armies could no longer rely solely on tanks to dominate the battlefield. Infantry armed with rocket launchers now had the power to level the playing field. The Panzerschreck also illustrated the speed at which wartime innovation could propagate. What began as an American invention, born of necessity, ingenuity, and a few makeshift materials, had been captured, dissected, and transformed by German engineers in a matter of months. It demonstrated the dynamic, almost Darwinian nature of military technology, where survival and advantage favored rapid adaptation. Weapons were no longer static tools, they were ideas that could jump from one side to another, evolve, and re-emerge stronger than before. Even beyond the immediate post-war period, the influence of this lineage can be traced through decades of military development. The shoulder-fired rocket concept inspired a succession of increasingly sophisticated systems, each building on lessons learned from the Panzerschreck and its ancestors. Modern anti-tank weapons, lightweight, portable, and capable of firing powerful shaped charges, owe their existence to this chain of wartime innovation. What started as an improvised American experiment ultimately reshaped global military doctrine, proving that a single idea, once unleashed, could echo across generations of engineers and soldiers. The story of the Panzerschreck also highlights the human dimension of technological adaptation. Engineers, soldiers, and commanders were all participants in an unspoken dialogue across enemy lines. The weapon embodies not just mechanical ingenuity, but strategic thinking, psychological warfare, and the relentless pressure of necessity. The Germans took an enemy tool, recognized its potential, and improved it in ways that exploited both science and battlefield experience. In doing so, they demonstrated that innovation often thrives under pressure, fueled by urgency, competition, and the high stakes of survival. Even today, the legacy is visible. Infantry units worldwide continue to rely on portable anti-tank systems. Modern RPGs, missile launchers, and shoulder-fired rockets all follow the basic design principles first realized in the bazooka and perfected in the Panzerschreck. This enduring legacy is a testament to the power of observation, adaptation, and technological transfer, even between enemies. In the end, the Panzerschreck reminds us that war is not only a contest of armies, but a crucible for ideas. A captured weapon, analyzed, improved, and deployed with precision, can alter tactics, reshape strategies, and even influence the course of future conflicts. From the deserts of North Africa to the snowy forests of Finland, from experimental workshops to the battlefields of Korea and beyond, the lineage of the Panzerschreck exemplifies how a single innovation, born in necessity and nurtured in adversity, can reverberate through history, changing the way wars are fought and the way soldiers see the battlefield. It is a story of ingenuity and adaptation, of observation and evolution. It is a story that proves a simple idea, a rocket on a soldier's shoulder, can become a defining symbol of modern warfare, transcending borders, influencing generations, and leaving a mark on history that endures long after the last shots have been fired. By 1944, the arms race between Allied and German forces had intensified, and the evolution of anti-tank weapons was accelerating at an unprecedented pace. The Panzerschreck, having been perfected from the captured bazooka, had forced the Allies to rethink the role of infantry in tank warfare. In response, the United States developed the M20 Super Bazooka, an upgraded version designed to counter heavier German armor, improve reliability, and extend effective range. The M20 featured a larger 3.5-inch warhead, a sturdier launcher tube, and a more dependable firing mechanism, directly addressing the weaknesses that German engineers had exploited in the original bazooka. The cycle of innovation, adaptation, and counter-adaptation was clear. Each advancement prompted a response, and the battlefield itself became a laboratory for rapid technological evolution. The legacy of the Panzerschreck extended beyond American improvements. In the Korean War, U.S. forces would rely on the lessons learned from both the bazooka and the Panzerschreck when facing North Korean and Chinese armored units. Soldiers understood the importance of mobility, surprise, and terrain in anti-tank warfare. Small infantry teams could now take on tanks, using the environment to their advantage while relying on weapons that had been honed through years of experimentation, adaptation, and combat experience. Meanwhile, the Soviet Union was observing these developments closely. Engineers there recognized the potential of portable anti-tank rockets and began developing their own designs, starting with the RPG-2 and later the iconic RPG-7. These weapons, while distinct from the bazooka or Panzerschreck, drew on the same fundamental principles: a compact, shoulder-fired launcher capable of delivering a high-explosive anti-tank warhead with deadly accuracy. The lineage was unmistakable. A single idea, born from American ingenuity, captured and enhanced by the Germans, had now become a foundation for modern infantry warfare worldwide. The impact of these weapons went far beyond physical destruction. Tank crews, once the dominant force on the battlefield, had to adapt to a new reality. Urban combat, forests, and narrow roads became hazardous, and armored units could no longer operate with complete confidence. Infantry armed with portable rocket launchers introduced uncertainty and forced tank commanders to adopt more cautious tactics. Combined arms strategies evolved, emphasizing coordination between infantry, artillery, and armor to mitigate the threat of these deadly new weapons. In parallel, specialized training programs emerged to maximize the effectiveness of these anti-tank systems. Soldiers learned not only how to fire accurately, but how to read terrain, conceal positions, and coordinate ambushes. The Panzerschreck and its successors transformed the tactical mindset of infantry units. No longer purely defensive, small teams could actively disrupt armored advances, control choke points, and dictate the flow of battle with precision. This represented a paradigm shift in the way infantry approached armored warfare. The technological and tactical innovations of this period also had long-lasting implications. The shoulder-fired rocket concept inspired a series of increasingly sophisticated weapon systems in the post-war era. From the Cold War through modern conflicts, infantry units around the world relied on portable, high-powered anti-tank weapons that trace their design lineage back to the bazooka and Panzerschreck. Modern RPGs, anti-tank guided missiles, and shoulder-launched multi-purpose systems all reflect the enduring influence of these mid-20th century innovations. Beyond the hardware, the Panzerschreck story illustrates a larger truth about warfare. Ideas can be as powerful as armies. Captured technology, once analyzed and adapted, can transform strategies, change outcomes, and influence generations of military thinkers. The weapons journey, from American workshop to German factory to battlefields across Europe and ultimately inspiring modern systems, demonstrates the extraordinary ways in which ingenuity, necessity, and adaptation intersect in times of conflict. Even decades later, military historians and engineers continue to study these developments, examining how a simple concept, an infantryman armed with a rocket, could redefine the balance of power on the battlefield. The Panzerschreck and its descendants became symbols of the potential for innovation to alter the course of warfare, showing that technology, once unleashed, has a life of its own. In the final analysis, the Panzerschreck was more than a weapon. It was a turning point in military history. It taught armies that even the smallest innovations, if used creatively and effectively, could reshape strategy and doctrine. It demonstrated the value of observation, adaptation, and the relentless pursuit of improvement. And above all, it proved that in the crucible of war, a single idea, once captured, reimagined, and perfected, can leave a legacy that resonates for generations, influencing how soldiers fight, how armies plan, and how wars are waged long after the last shot has been fired.